This is your beginning algebra final exam review. These are some of the problems from the worksheet that I put in Canvas for you. This is just for the spring of 2020, very abbreviated review here. So number one, -1 times 7 times -3. So I like to do my signs separate, but if you want to keep up with it, that's fine. If you multiply -1 times 7, you get -7. If you take -7 times -3 here, then you get a negative times a negative is positive, and 7 times 3 is 21. All right, 21. So let's go to number 2 here, just underneath it. 5 minus -7 plus -13. If you notice in number 1, there's nothing between the parentheses. That tells me I'm multiplying. But here, there's a minus sign here, and there's a plus sign between the parentheses there. Those are not being multiplied. You are taking 5, and then you have minus a -7. This separates a new term, and it's minus a negative, okay? So then if I subtract a negative, here, that really means plus, okay? So this is a 5, this is a 7, and this is a 13. Minus a negative means plus, okay? Minus a negative means plus. So let's go ahead and, no. Go ahead and take that away. Oops. All right. And then what does plus and negative mean? Well, plus and minus, look, the signs are being multiplied, but 7 is not times 13 here. It's just a positive times a negative. And a positive times a negative is negative, just like this is a negative times a negative, but it's not 5 times 7. It's 5, and then minus all of this stuff is a new term, okay? So 5 plus 7 minus 13. That simplifies it down to one sign per number or term. So then 5 plus 7, they're both positive. Add them together and keep it positive. 12 minus 13 is, right, 13 is bigger than 12. You subtract, which is 1. 13 minus 12 is 1. And you keep the sign of the larger. 13 is bigger than 12, so keep the negative. So that answer is -1. Number 5, 4/5 minus 5/6. This is some fractions. That's okay. We can handle this. We're going to do 4/5 minus 5/6. So if we subtract two fractions, then that means we have to find the LCD. And in this case, your two denominators are 5 and 6. You always ask yourself, does the smaller 5 go into 6? No, it does not. So then you say 6 times 2, which is 12. Does 5 go into 12? No. You do 6 times 3, which is 18. You do multiples of 6. 6 times 2, 6 times 3, 6 times 4, 6 times 5. So if I go through them, 12, 18, 24, 30. 30 is the first multiple of 6 that 5 divides into, so my LCD is 30. All the other denominators, in this case, all the other ones are just 5, have to go into a multiple of the largest denominator, okay? So here, 30, so then we're going to say this is 4/5, and we have to multiply this by something because that's not already 30. If that was already 30, we wouldn't multiply by anything, but it is. Minus, that's this minus sign here, okay? And then 5/6, and also, because this is not already 30, then guess what? We have to multiply this one by something. So I'm going to take this and change over to my green here. I'm going to say, okay, what do I multiply by 5 to get 30? 6. So if I put a 6 down here, I have to put a 6 up here because 6 over 6 is what? That's just 1. That's why we do this. Don't cross anything out here. 6 over 6, okay? And then what about the next one? What do I multiply by 6 to get 30 here? 5. So if I put a 5 down here, I got to put a 5 up here. So these numbers have to match here. They don't have to be the same. Those are not the same, no, okay? But they have to be the same above and below each other. So like 6 over 6, 5 over 5. You can't put 10 over 5 or 20 over 5. Not if you're just finding a common denominator, okay? So now we want to multiply. Look, here's a minus sign. You have to do this term and this term separately right now, okay? So we're going to say it's going to be something minus. It's going to be a fraction and a fraction, okay? This fraction goes here, all right? So then you multiply straight across. 4 times 6 and 5 times 6. What is 4 times 6? 24. 5 times 6 is 30. Don't try to simplify that number because you're trying to combine these two fractions. The whole point is, what is 6 times 5 over here? 30. Now you have a common denominator, right? You just need to figure out what goes here. So what is 5 times 5? That's what goes right there. It is 25. Now you have a common denominator, so all of it can go over 30, and you do the top with the sign there, right? You do 24 from the first fraction. You have a minus sign, and 25 from the second fraction. 24 minus 25 is -1 over 30, and that's okay there, or they may, if it's multiple choice, it may look like this with a negative out front, okay? Either answer is fine. They're the negative out front or negative 1 over 30. It's going to look like one of those two somewhere, okay? And one of the answers. Number 6, you are what? You have a fraction divided by another fraction. This is not two terms. It's this division, so it's all one big thing. You don't have to find a common denominator like you do when you add or subtract. Even though you have this negative out front, that just means the first fraction is negative. So negative 4/5. How do we do this? We keep, we change, and we flip. So we kept negative 4/5, negative 4/5. That's the keep part. Change, we're going to change this to what? Times. And then we're going to flip this fraction. So 6 over 5 is going to become 5 over, I'm sorry, I said it backwards. 5 over 6 becomes what? 6 over 5. So now we're multiplying two fractions. You multiply straight across, but the other thing you can do is, can you divide anything out? On this, you want to divide something out because you're not trying to find a common denominator like you were over here. Over here, you want to leave it and don't divide things out right now. You would divide it out down here in the answer, but there was nothing to divide out, okay? So here, does 4 divide out with anything down here? Nope. What about 6 down here? Nope. So just multiply straight across. 4 times 6 is what? 24 over 5 times 5 is 25, and then one's negative and one's positive. What's a negative times a positive? Negative. So negative 24 over 25. So negative 24 25ths. And again, you would ask yourself, does this simplify any further? And it does not. So you don't go any further. Same thing here. You couldn't do any more with that. So you're done. So look at number 7. It's actually simpler than number 6. Number 6 is just like number 10, by the way. We'll get to that in a second. But number 7, 5/8 times 2/6. Well, multiply. You don't flip anything. You don't change anything. You just multiply straight across. So this is actually the same as this step right here. So it's actually a smaller problem than 6. Now, does anything divide out? Well, let's ask ourselves, does the 5 divide out with the 8 or the 6? Nope. What about the 2 with the 8 or the 6? Either one, but not both. So you pick. I'm going to say the 2 and the 8, but you can say the 2 and the 6. We should get the same answer. How many times, what goes into both 2 and 8? 2. 2 goes into 2 once, and it goes into 8 4 times. If you wanted to take the 2 and the 6, it would be 2 at 1 over 3, but don't mess with the 8 in that case. So then multiply straight across. 5 times 1 is what? 5 over 4 times 6 is what? 24. So 5 over 24, and then you would check it again. Does anything divide out here? Nope. Let's say that you missed this here and you did 10 over 48. Well, look, both numbers are even, so now take a 2 out. How many times will 2 go into 10? 5. How many times will 2 go into 48? 24. So you end up with the same answer, all right? Even if you don't see that the 2 divides out in the original problem, you still simplify in the end. So it should work, or it will work either way. So look at number 10. Number 10 is actually just like number 6. We're going to keep, change, and flip. I mean, the numbers are different, but it works the same way. We're going to keep, change, flip. And this time, look, the negative is up here with the 2. This time it was out front. It's the same thing. It's negative. It's a negative fraction. So negative 2 over 9. Keep that. Change this to times, and then flip this to 15 over 4. And then we ask ourselves, does anything divide out? Well, look, first of all, let's take our sign. We have a negative times a positive, so my final answer is negative, and I got a fraction, okay? So this is my negative sign. This is my fraction line, okay? And I just brought the negative out front of my fraction. You can leave it up top. Doesn't matter. I'll write the answer both ways. So the 2, does anything divide out with the 2 here? The 2 and the 4, right? So 2 goes into 2 once and 4 2 times. And then what about the 15? Does anything divide out with the 15? How about the 9? They both have a what in common? A 3. They both have a 3 in common. How many times does 3 go into 15? 5. What about 9? 3 times. So you want to try to do this at this step to make your multiplication smaller and easier, and also easier to check your final answer to see if anything else goes into it. So here, 1 times 5 is up top in the numerator. That's 5. We've already taken care of our negative out front. And then what in the denominator? 3 times 2 is what? 6. Does that simplify anymore? No. So then my final answer is negative 5 over 6. Or if you wrote it like it would be negative 5 over 6. Okay? Either one of those would work. Either one of those would work. Just make sure you know those are the same thing. So if you write your negative out front and the answer on the answer sheet has negative 5 in the numerator without the negative out front, you need to know those are the same, or vice versa. If you get negative 5 over 6 and it has negative out front 5 6, then you need to make sure that you understand that's the same thing. All right? So let's look here. We're going to skip all the way down to 23. We're going to do 23, 25, 29 on this page. Solving for x. All right? Solving these equations. How do I solve for x? Well, look, this 5 is positive, and So we need to subtract it from both sides, get rid of it, right? That cancels and goes to 0. X equals, what do we do when we have two negatives? We add them. 5 plus 7 is 12, and we keep it negative, and that's the final answer. X equals negative 12. That was one step, okay? That one was one step. They'll get more complicated, don't worry. So then what about number 25? 3 minus 2x equals 9 minus 8x. This one has both numbers and variables on both sides. So you pick any one thing to move. I'm going to move the negative 8x, but it's not wrong if you move the 3, the negative 2x, or the 9. Okay? So I'm going to choose to move this to the other side. How do I move it to the other side? I add it to both sides. Okay? So I'm going to do this in two separate steps. This first part, I want you to get to the point where you do it in one step. Okay? And you may already be there, and that's fine. So this cancels on the right. That's why I did it. I'm left with 3 and then plus 6x equals 9. All right? So this is the step that you could have done on the same step. You could have said, hey, I'm getting rid of this over here on this side, so let me get rid of this one over here, and you could have subtracted 3. Okay? But I'm going to do that on the next step. So now the only thing over here is a number. Move this 3 over there with it. How do you do that? Subtract 3 from both sides. Right? So that cancels, and we're left with 6x equals 6. And then finally, what do we do here? We have to undo the times 6, so we divide by 6. 6x over 6 is x, and 6 over 6 is 1. So our final answer there is x equals 1. You could have gotten to that answer in a variety of ways. You could have correctly arrived at that answer in at least 4 different ways. At least. And then maybe some other way that I'm thinking about. Maybe might even get, say, 8 or something, depending on how you did it there. Okay? But you could get to that answer a variety of ways correctly. Okay? So if you did it a different way, that's fine. If you got x equals 1 anyway. All right? Or most likely fine. 5x over 4 minus 1/2 equals 6. So this one, the ante is upped a little bit because we have fractions, right? When you have an equation, so I want to go back and look at something. Was anything on this screen an equation? No. Why? Because nothing on this page had an equal sign in it to start with. These were all expressions. We were simplifying expressions. Over here, we're solving equations. I didn't put that on here. It's in the directions on the worksheet that you're solving for x here for the variable. All right. So here, when you are solving, when you have an equation, you can multiply everything on both sides by the LCD, and in this case, 4, right? The only denominators you have are 4 and 2. I mean, this is over 1, but 3 is not a denominator, okay? So you ask yourself, does 2 go into 4? Yes, it does. So 4 is the LCD, okay? 4 is the LCD. So that means I can take and multiply. What I'm doing is I'm really multiplying the whole side by 4, but then I'm distributing, okay? So when I distribute, I end up with 4 times 5x over 4 minus 4 times 1/2 equals 4 times 3. Put my parentheses there, okay? And then I'm going to remind myself, hey, this is really over 1, okay? Those divide out and become 1s. That leaves me with 5x minus 4 over 2 becomes 2 and 1. Then I say 2 times 1 is what? Minus 2 equals, and over here, what is 4 times 3? 12. And now look at this. That's not my answer, but that's something that's much simpler to solve than what I started with. So if I look at this, how do I solve it? Well, the thing by itself is 12, so move this negative 2 over there with it. How do I do that? I'm going to add 2 to both sides. So 5x equals 14. And then what do? Divide both sides by 5. And it doesn't go into it evenly. It's not a whole number, but that's okay. The answer is 14 fifths, or 14 over 5. Okay? The answer is 14 fifths, or 14 over 5. All right? X equals 14 over 5. (10x minus 3) and then x minus 2 equals 12 plus 5x. So let's see, we have, we're going to distribute this. We're going to simplify both sides. This side's already simplified, but we need to simplify this side before we start moving stuff from one side to the other. Okay? Once you get really familiar with the rules, if you want to change that order up, that's fine. But right now, we're going to simplify both sides completely, then determine what we're going to move from one side to the other after we simplify. So this 10x stays out front. Look, the 10x is not times everything. The negative 3 is times everything. So negative 3 times x is negative 3x. And then negative 3 times negative 2 is what? Positive 6. So then I'm not even going to worry about the right-hand side right now. Is there any more work I can do over here on the left-hand side of this? Sure, I can put the 10x minus 3x together and get 7x plus 6 equals. Can I do any more work over here? No. Now let's go to the other side and say, what can I do on this side? Well, we already said there's nothing to do over here, right? So just bring that down. 12 plus 5x and 12 plus 5x. Now you determine, hey, what am I going to move from one side to the other? I'm going to move my 5x, but there's nothing wrong with moving any of the other terms here, the 7x, the 6, or the 12. So if I do that, that cancels. I'm left with 2x plus 6 equals 12. And now what's the best move? 12's by itself, so move the 6 over, right? So how do I move it over? I subtract it from both sides. 2x equals 6. And then what do? Divide both sides by 2. So x equals 3. All right? X equals 3 for number 30. All right, 33 and 34, if you notice, are not equations, but they're inequalities. We call them that because they have the less than or the greater than in there, right? Or less than or equal to or greater than or equal to. Those are 4 separate symbols, all right? There's no such thing as not equal to. Well, there's no such thing as greater than or less than. That's called not equal to. And we don't solve anything with that in here, I don't believe, all right, that I remember anyway. So what we'll do, some of these questions may stop at the inequality answer, and some may go all the way to the interval notation and all that stuff. I think these just say solve the inequality, right? Solve the inequality. But for practice, I may go ahead and put the number line and do the interval notation for practice. But if you're on the final and it stops at x is greater than 6 and you get that answer, then pick it and go on. Don't keep going, right? So look at the answer choices when you begin the problem and say, oh, I'm looking for just x is greater than 6 or x is less than 9 or whatever, not 9 with a parentheses, comma, infinity with a bracket, or, well, it won't be a bracket on infinity, but still. You're not looking for brackets and infinities and that kind of stuff, brackets and parentheses and infinities and all that stuff, if you just do inequality. So here, x is on one side, numbers on the other. The only thing you do is divide by the coefficient of x. But when you divide an inequality by a negative, that changes the sign. It was greater than, it becomes less than because you divided by a negative. A negative divided by a negative is positive, and 12 over 3 is 4. So x is less than 4. There is your inequality answer for that. So if the answer stops at inequality, I believe this one does maybe, then there's your x is less than 4. However, let's just keep going just for food for thought. Just food for thought here. If I had a number line here, I would go 4, less than is this way, shade it, parentheses on it because it's not equal, and then this is negative infinity. So my interval notation is negative infinity to 4, parentheses around them, all right? So if it asks for interval notation, this would be your answer. If it just says solve and these are all your answers look like this, then that's it. You don't have to do all this stuff I did in blue right here. Okay? So just that's up to you to see that, or either the directions to tell you, hey, put this in interval notation or not. All right? So I'm pretty sure this one stops here, and the other one does too. But again, for practice sake, because I think I do have one on here where we're going to transform this into this. So we'll just get some more practice at it, right? No harm, no foul on that. Let's practice it. So 34, let's solve it and then put it in interval notation just for fun to practice right now. Okay, so here 5x minus 2, or 5 times x minus 2 is 5x minus 10, right? Simplify that side. Also, simplify the other side. You got to distribute the 2. So 2 times x plus 1 in parentheses means 2 times x, 2x. 2 times plus 1 is plus 2. So now we have it, and I'm going to move my 2x by subtracting it from both sides, okay? I know that cancels. If you want to go ahead and move this at the same time, you can. I'm not going to right now, but that's where I want you to eventually get to. 3x minus 10 is less. Do we change the less than or equal to this time? No, we don't, because all we did was subtract something. Only if we multiply or divide by a negative number, okay? So Now there's a best move. My best move now is to move this negative 10 over because the 2 is by itself. So add 10 to both sides. That cancels. 3x is less than or equal to 12. And then what do? Divide both sides by 3. Did I divide by a negative? Nope. So leave it less than or equal to. X is less than or equal to, and 12 over 3 is 4. So this is my inequality. I solved it. But what if we wanted to practice writing in an interval notation, or it asked for that? Then I'm going to come over here and say, okay, 4 is my answer, and I got a bracket around it, right? And I want to shade greater, which is to the right. Oh, that's not correct. What does mine say? What does that say? That doesn't say greater than. What does it say? It says less than. So let's fix that, okay? Let's fix that. I was just seeing if y'all were awake, all right? So then it's going to be less than. It's going to be open back this way towards negative infinity again. That's this infinity over here, this arrow. So we have parentheses, negative infinity, comma 4 with a bracket. Okay, that's our interval notation. Interval notation there. And again, what we were really solving for there was just the inequality, I believe, if I have that correctly in my memory. But I wanted to go ahead and show you that because maybe the next page, it may be further down the page, but somewhere I have one of these where we're going to go straight from this to this. And so we need to know how to do that, and that's just extra practice, all right? Extra practice. Here it is, first one here, actually. So x is less than or equal to negative 3. So on my number line, I have negative 3. Which way is less than? To the left. I should have given you one greater than on here somewhere, huh? All right, negative infinity, and this is a bracket, right? Because of the equal to says bracket. So this is going to be negative infinity, comma negative 3. Negative 3 has a bracket. Negative infinity has an in parentheses every time. Okay, and I'm just going to look back and make sure we did these two properly, right? Yep, negative infinity to 4 with a parentheses on that one and a bracket on that one. They're right. Okay, so looks like I went across the top this time instead of down. So we'll go to 59 next. All right. So you know the other pages I went this way and then up here, but on this one I go across here and then back over here. All right. So let's fix that here. 59, 6x squared y cubed plus 12xy squared. So what we're really doing here, what we're really doing on all these is factor completely. Okay. That's what we're doing on the rest of them from 59 all the way out. Is factor completely. So here there's two terms, right? One term, two terms. If there's two terms, we're either looking for a GCF or difference of squares in this class. There's one more thing we'll look for later on in your math life, but right now, this class, GCF or difference of squares. Well, this is a GCF. Difference of squares would have to be different signs, and they're both positive, so it can't happen. So here, this is going to be 6 is in common with both, right? 6 goes into both 6 and 12. How many x's does each term have? Well, this one has 2 and this has 1. So as long as they all have x, you take out the lowest power, one of them, x to the first. And then what about y's? They both have y's. What's the lowest power? Y squared. So then if I take 6xy squared out, then that leaves me with what? Well, I took the 6 out. I took one of these out, so I have an x, and I took one of these out, so I have a y. So I'm left with, let me fix that. Just an x and a y, and then plus, because I didn't take a negative out to change that. How many times will 6 go into 12? 2 times, right? And then I took the x and the y squared out, so there's no x's or y's left. So just xy plus 2. So then 6xy squared times xy plus 2. 61, x squared plus 13x plus 36. And one of the ways that I have seen math teachers try to make sure you don't just multiply stuff out and FOIL or whatever in the answer. They'll say, okay, here's your answer choices. X plus 4, x plus 6, x plus 9. Oh, wait a minute. Let me fix that. X minus 9 and x minus 6. Here's your 4 answer choices. Tell me which one of those is a factor of, right? Instead of factor the whole thing that you could sit there and multiply all the answers out and see which one gets it, they say, here, do this. So which one is it? Well, let me just leave those up here for now. This is going to be x and x. If it works, look, it's how many terms? It's 3 terms. Is there a GCF? No. There's a 1 in the front and not an x in every term. That's a quick way to glance at it and see there's no GCF. So then you ask yourself, if the 3 terms, no GCF, what is this first number? It's a 1. So therefore, it's It's called list method. We want to list out the factors of 36. The factors of 36 that add to give me 13, what are they? They are 1 and 36, 2 and 18, 3 and 12. Some of these you may not be familiar with. 4 and 9, 6 and 6. So all those things multiply to give me 36. Do any of them add to give me 13? 6 plus 6 is 12. That's not it. 4 plus 9 is 13. Aha, 4 plus 9, right? That gives me 13. So then we're going to put a 4 and a 9 in here, and then both signs are this one. Both signs are positive. Right? This says they're both are different, bigger or both. That says both. They're both the plus. Okay? So plus 4 plus 9. So go watch the list method video if you need to. All right? On factoring for that one. X plus 4, X plus 9. All right? And that's the answer. But then what if I said, look, which one of these is my answer? Well, it's this one, right? That's not in there, that's not in there, and that's not in there. So it's that one. Okay? So that's the way that math teachers can get around letting you multiply them out. Because if all the answers look like this, you can just FOIL. So let me erase that there. But that's just a way you could do that, or it could be asked. All right? So let's see. Let's knock these last three out. This is the same thing. 3 terms, no GCF on 64 with a 1 in the front. So this is list method, and we just saw these factors. So just list them out again. Look, once you've already factored something, just go back to wherever it was and copy them down. That's what I did there. Just boom. All right. And this, if it works, it's going to be X and X. And then factors of 36 that subtract to give me 35. What are they? 1 and 36, right? 36 minus 1 is 35. So put in here 1 and 36. It doesn't matter if you put the 1 in the first parenthesis or the 36 in the first parenthesis. What matters is you get plus 1 or minus 1 right. Plus 36 or minus 36. Look, forget this sign is here. This all by itself says that these two signs are different, okay? That minus all by itself says they're different. So the way we read it is we say the bigger number gets this sign. And I mean bigger of these two. Which one's bigger? This one. That gets the plus, okay? That gets the plus. So plus 36, and since they're different, that's got to be a minus. The only way to get a negative 36 is if you multiply two opposite signs, a plus times a minus. So again, you would look for, if it ask it like the other one, said, hey, which one of these is a factor, you'd look for either x minus 1 or x plus 36 in there. 63 is how many terms? It's 2 terms. 2 terms, it's either a GCF, here's their GCF, no, or it's difference of squares. Is this difference of squares? Yep, even power, minus, and a perfect square. It's difference of squares. Technically, positive and negative, they're different signs. All right, so then this is going to be x and x, because what do you square to get x squared? X's, right? Now here you put, what do you square to get 25? That's right, 5. So 5 times 5 is 25, and it's different signs. One is plus and the other is minus, and you're done with that one. Those are not identical parentheses, so you don't write them as something squared. That's not how this one works. And then what about x squared minus 10x plus 25? Okay, 3 terms. Is there a GCF? No. Is the 1 in the front? Yes. So this again is list method. 1 and 25. 2, 3, 4 don't work. 5 and 5. So I want the factors of 25. Let me write down x and x. The factors of 25 that add to give me 10. And I'll worry about the negative in a minute. So it's 5 and 5, right? 5 and 5. And here the signs are the same. I know these are different. That's not what I'm talking about. This alone tells me these are the same down here, okay? And it says they're both whatever this sign is. So that negative goes in both places right there. So then minus here and minus here. But I'm not done unless it says, hey, what's a factor? And x minus 5 is the answer, right? But if I want to factor it completely, I don't want to leave it x minus 5 times x minus 5. Those things are identical, unlike this one. This is plus and minus over here. So it's not identical. These are identical. So it's going to be what? X minus 5 squared. And that's my final answer there, right? That's my final answer there for number 68. So for these are the ones that I chose to work for you. I know that things are crazy right now, so if I had to focus on stuff, I'd focus here first and then work on the rest of the review later. You got some time, a week or so, to work on the review before the final opens up. So make sure you get all your My Math Lab homework done, the remaining MML assignments module there. Make sure you have all your tests taken. Make sure you've submitted your screenshot for the bonus points. And good luck.